Hello students, today we are going to discuss a topic which is called operator overloading. Operator overloading is a kind of polymorphism. We already know what is polymorphism. Polymorphism means one thing has multiple forms. That is one interface and multiple implementations. We have seen polymorphism in the form of function overloading, right? And the second kind of polymorphism is through operator overloading. So the two ways to achieve polymorphism in C++ are function overloading and operator overloading. In function overloading, or also we can say we achieve this using function overriding. It means we have one interface, that is the name of the function is same. Suppose it is void show. So interface is same, but we can have different implementations. The same show function can be used to show a rectangle, it can be used to show a triangle, it can be used to show a circle. So the implementation details are different, but the interface is same, right? This is the polymorphism which we can achieve through function overloading. And the second kind of polymorphism is operator overloading. Operator overloading, just to give you an idea, suppose we have this addition operator. Normally, we use this addition operator to add two integers. It can also be used to add two doubles. But if we change the behavior, we have to change the behavior of this plus operator so that it can be used to add two user defined data types, then we can say that the addition operator has been overloaded. What do we mean by user defined data types here? For example, the class distance. We are very familiar with this class now. This class contains two data members, int feet and in inches. I think it is not int feet, it is double feet. Okay, so this distance class has two variables. Okay, so if we want to add two instances d1 and d2 of this class, then we need to define an add function, right? This add function will take an instance of suppose d1, and here we create a temporary object distance t, where t is equal to d1 dot inches plus this dot inches, right? What is this dot inches? This dot inches means the calling object through which we are calling this. Okay, suppose we are calling this using the d2, then d2 dot add d1 is equal to d3. This will be the statement through which we can call this add function. Okay, it means we have two objects d1 and d2. d1 has its own values for feet and inches, suppose 6, 5. This is d1, and d2 also has its values for feet and inches respectively. Okay, then we are calling d2 dot add d1. It means we are calling this add function, which is a member of this class, through the object d2. Okay, so the d2 is the calling object, and what we are passing the second object d1, right? D1 we are passing. Then inside add we are creating a temporary object, and then temporary object will uh, be equal to the sum of feet and inches of d1 and d2. That is d1 dot inches plus this dot inches. It means d1 dot inches plus d2 dot inches. Okay. Similarly, it will calculate the value of feet. Then at the end we will return t, and this returned function will be this returned object will be assigned to d3. Okay, so it looks very cumbersome, right? D2 dot add d1. Can't we write simply d3 is equal to d1 plus d2 or d2 plus d1? Why can't we do this? We can of course do this, and this can be done using operator overloading. Okay, so here what we are doing, this plus object is now overloaded. Why? Because now it is not operating on integers or doubles or floats. It is operating on a user defined data type. When a normal operator is operating on user defined data types, then we say that the operator has been overloaded. Okay. So the same example which I gave you, it is d3 dot add objects d1 and d2. So this is same. In the previous example, we had this interface. D3 is equal to d1 dot add d2. Okay. And here we have d3 dot add objects d1 comma d2. It means now in this case the function will look like add objects distance d1 comma distance d2, and it will not return anything, it will be void. In the earlier case it was returning an object of type distance, and the name was add, and here it we were passing an object of type d. So this was the interface in this case, and in this case this is the interface. Okay, so here what will happen, we do not need to create any temporary object. Okay, because we are calling it through d3. So here what will happen, inches is equal to d1 dot inches plus d2 dot inches, and feet is initially 0, and if inches is greater than or equal to 12, then feet plus plus inches minus equal to 12, and then feet is equal to d1 dot feet plus d2 dot feet, right? And how to call this add object? Remember, this add object is a part of class distance. Okay, we have other data members and member functions, but we also have add objects. And in the main function, suppose this is your main, in the main function we have distance d1, suppose 3 comma 4, distance d2 7 comma 2, and then distance d3 where d3 dot add objects d1 comma d2 will result in calling this function. And what this function will do, this function will add the data members of d1 and d2, and those values will be stored in the data members of d3, right? And if we have this kind of interface, then what will happen? Instead of void, we will have a return type dist, and instead of having two parameters, it will have only one parameter. And because this is returning an object, we need to create some temporary object which can be returned, right? And here we will write t dot inches is equal to d1 dot inches comma plus just inches or this dot inches. Okay, feed t dot feed is 0, and if t dot inches is greater than equal to 12, then t dot feed plus t dot inches minus equal to 12, t dot feed is equal to d1 dot feed plus feed, or you can just write this dot feed. Okay, and here how will we call this? We will write d3 is equal to d2 dot add objects d1, right? So this is how we add two objects without using operator overloading, right? So before moving forward, let me erase this ink. Okay. This is the second form which I explained. Okay, so both these statements are clear to us. Here we are passing two objects and it is not returning anything. Here we are passing one object, and through the second operand, so here we have two operands d1 and d2. We want to add d1 and d2. So these d1 and d2 will be called the operands. So here we are passing both the operands, and here we are passing only one operand, and the second operand is passed implicitly. We are not explicitly passing it. It will be passed implicitly because we are calling this add objects through this object. Okay. But we can change this to much more readable form through operator overloading. That is, we can write d3 is equal to d1 and d2. But this is possible only if we overload this addition operator, right? So now what is the definition of operator overloading? The term operator overloading refers to giving the normal C++ operators such as plus, multiply, less than equal to, plus, equal to additional meanings when they are applied on the user defined data types. As I already said you, we say that an operator is overloaded when it operates on user defined data types, right? So how to overload an operator? An operator can be overloaded using the special keyword, that is the operator keyword. And the syntax for overloading any operator is, this is just like a function. This is a special function, and the function has a return type. Here we have written void. Then we have this operator keyword, and then we write the operator which we want to overload. Here what are we doing? We are overloading the increment operator, and then we have the parenthesis. So this parenthesis is the indicator that this is a function. This is actually a function. But this is a special function. Why a special function? Because this is used to overload an operator. How the compiler knows that this is used to overload an operator? The compiler knows it by looking at this operator keyword. Whenever this operator keyword is encountered, it means we are defining a function to overload an operator. Which operator? The operator which is written just after the operator keyword. Okay. So the return type which is void in this case comes first. It can be void, it can be anything else also. Followed by the keyword operator, followed by the operator which you want to overload. In this case, it is increment operator, but you can overload any other operator. And then finally, this parenthesis. Here, this parenthesis is empty, but it can also contain some parameters, right? So, this is the interface for the function which you want to use for overloading an operator, right? This declarator syntax tells the compiler to call this member function whenever the operator plus plus is encountered. Whenever you are writing any operator plus plus, increment operator anywhere, then the compiler calls this operator. Okay, so suppose you have this show function void show. Okay, so uh, whenever you write show, then what happens? The compiler, whenever it encounters this kind of statement, show parentheses and semicolon, it knows that this is a call to the show function. So it calls the show function. Similarly, suppose you are overloading the plus plus operator, void operator plus plus, and here we have the code to overload this operator. And in the program, whenever you encounter plus plus, then it is also a call to this function. Okay. So the declarator syntax tells the compiler to call this member function whenever the plus plus operator is encountered, provided the operand. We also need we cannot say that whenever this plus plus is encountered, then this will be called. We also need an operand, right? So here D1 is the operand. D1 is the operand. Okay. So the variable operand is the variable operated on by the operator. Okay. So whenever this is encountered, then this makes a function call to this operator overloading code. Okay. So in order to understand it more deeply, we will take the help of an example.